In this video, I'm going to explain how to write a CNC program for phasing cycle. Now let us see that for phasing cycle how the tool will move, that I want to explain here. To take for any program, any mission, there is a reference point. First, we have to identify a particular mission, which is the reference point, and we can mark that reference point. Then the tool will always, before start the program, it will be there at the reference point. But changing the tool also will take place at reference point only. Now we can just mark this the tool entry point, that is 1, and the tool will move from reference point to the entry point. Then from entry point to the second point, you see that the second point, this movement is in air. So without machining, this tool will move. So rapid movement we can assign to this movement, that is 1 to 2 is the rapid movement, that is the written P1 within the bracket R. R indicates the rapid feed. Then we'll goes to the point 3. Okay, there is a phasing operation. So from 2 to 3, it is the metal cutting takes place. Then at a given feed rate, the tool will move from point 2 to point 3. Then from 3 to the point 4. So this is also, so material will cut in this process. So it's also feed, given feed, the tool will move. That is the P3 of F. Again, from 4 to 1, it is a rapid movement. Okay. Now in this cycle, it's a phasing cycle. It will take care of all these 4 paths. That is 1 to 2 is the rapid path, and 2 to 3 is the feed, and 3 to 4 is the feed path. Again 4 to 1 is the rapid. This is the complete one cycle take care by using this phasing cycle. Otherwise, you have to give the individual the movement of the tool from path 1 to 2, 2 to 3, 3 to 4, 4 to 1. How many that lines are required? Here 4 blocks are required to complete these 4 movements. Instead of the 4 blocks, only the single block is accompanied these 4 operations. That's you are using the phasing cycle. We'll see that when writing the program how it will be written. Now let us see that what is the syntax generally we are using for the phasing cycle. That is the G94 X of U, Z of W, F. G94 is using for the phasing cycle. Okay. So X is equal to diameter to which the movement is being made. And within the bracket U, that is incremental distance from the current tool position to the required final diameter, that we have to assign X of U in the brackets. Next, Z indicates the Z-axis coordinate to which the movement is being made along the Z-axis. W indicates the incremental distance from the current tool position to the required Z-axis position. And F indicates the given feed rate. This is the simple the syntax using for phasing cycle, that is a G94. G94 indicates the phasing cycle. So I explained the 4 path. The tool is moving from 1 to 2, 2 to 3, 3 to 4, 4 to 1. All 4 will take care of by single this block, the G94, X of U, Z of, and F. Now let us see that an example of the phasing cycle program. Now I want to phase machining the phasing with this given job. Okay, so the outer diameter is 50. Now it reducing from 50 mm to 15 mm with the 8 in axial. That axial depth is 8. That is Z-axis dimension is 8, and the X-axis is reducing from 50 to 50. Now we have to because the N10, G21, G98. So the G21 is the metric unit, G90 is feet per minute, and N15, the year N10, N15 indicates the block numbers. G28 U0 W0. It indicates the tool will move to the homing position. Next, N20 M06 T02. The tool will change to T02. M06 indicates the tool change to to T02. After changing the tool, then you can assign the speed. The spindle speed is S1100. M03. M03 indicates the spindle starts rotating in clockwise direction. And G00, that is the rapid movement of the tool from the reference point to the tool entry point. Here I define the tool entry point is X55 Z0. Okay. Now you can indicate this is the 0, both X and Z are 0. Now exactly Z dimension 0 here, little just 5 mm above the workpiece, I want to bring the tool to make the cutting operation. That is the tool entry point. Next, we can assign the facing cycle, that is N35, G94, X15, Z-2, F60. Okay. Now I given 2 mm depth, that is the Z-2. So from 0 to 2 mm it will go to inside the material and the material cutting takes place. So this is the complete one cycle. Next, you can another block we can give the Z-4. That is in one cycle the 2 mm material is removed. Next, total I want to remove the 8 mm. So next cycle 4, next cycle 6, and next cycle 8. Like that, the within the 4 the blocks complete cycle is completed to return the program. It's very simple and short while using the cycles. So once that 8 mm completed, then the tool will move to the again homing position, G28 U0 W0. Then spindle stop, M05 is a spindle stop. Then M30 is a program and a rewind. Program and rewind. So this is the simple facing cycle program used to cut the faces of the work pieces. Now in this example, I want the 50 mm diameter that will be reducing to 15 mm in 8 mm the Z direction depth. That is, you can use either here plane turning cycle also you can use to machine, but better you can use the facing cycle, because here the dimension of the X dimension is more than the Z dimension, then you can use the facing cycle. If Z dimension is more than the X dimension, then you can go for the plane turning cycle. I hope everyone can understand this program.